Hello and welcome to another video by Don Perry Automotive, and today I'm going to show you the 4-stroke cycles of the engine and also the importance of checking your valve to piston clearance and valve to valve clearance. So let's go. I'm going to play this animation and you will see the exhaust valve, which is here on the left. The exhaust port is here, the intake valve, which is here, and the intake port is all of this here. So let's go. Just watch and figure out each of the strokes in the 4-stroke cycle, right? Cool. So this is the intake, compression, power stroke, and exhaust stroke. Intake, compression, power, and the exhaust stroke. Now that we've gone over the 4 strokes of the 4-stroke engine, so now let's look at the clearance between the intake and the exhaust valves. All right, so let's go. I'm going to start at the middle of the exhaust stroke. That's power. Okay, so exhaust is here. Now the exhaust valve is being pushed down by the camshaft lobe. Your gas is being expelled. And you can see that the piston is very close to the exhaust valve. Let's go back a little bit. Go forward. See, piston is basically touching the exhaust valve, or if you have deep pockets, then it would have been in the pockets of the piston. Now if we wanted to increase safety or clearance between the valve and the piston, the exhaust valve and the piston, what would we do? Would we increase, would we advance the timing on this camshaft, or would we retard it? Advance would mean it will open earlier and close earlier, and retard means it will open later and close later. And right now this is closing a bit too late, right? Just for demonstration purposes only, this is closing a bit too late. So we would have to advance the exhaust valve cam so that the exhaust valve would open earlier and close earlier, so it makes its way out of the way of the piston, right? So it would have been closed already, or it would have been up here instead of down here had you advanced the camshaft for the exhaust, right? Let's move on, and moving forward we can see that the intake valve is being open while the exhaust valve is still open. This is what we call overlap. There is this brief period where both valves are open, right? Intake is coming in, exhaust going out, but sometimes the exhaust, the pressure is greater on the exhaust side than the intake, and we have some of the exhaust gases coming back. If you see this arrow, it is pointed the other way. It is telling me that some of the gases is going that way. This is called reversion, right? And for that brief period of time, you will have the valves overlapping each other. Now reversion, you can hear reversion taking place when you have big cams and that's because some of the exhaust gas is making way back into the intake and causing a little bit of tumble right there. So let's go now. See the intake arrow has changed because the pressure differential between it is greater on the intake side. So now the intake valve is going to push down, but if you notice the valves are very close to each other, we can almost say this is touching. What do you do to increase valve to valve clearance? Well, you widen, you separate them. Notice this curve right here and this curve right here. right? So this is the exhaust and this is the intake. You would have to narrow this overlap right here. So you'd have to advance the exhaust valve or retard the intake valve, right? And this would give them some degrees of separation from each other. You can do either advance and leave the intake alone, or you retard the intake and leave the exhaust alone, or you do both, right? As long as you're separating them and increasing the clearance between them, because you don't really want both of them opening and colliding. That would damage your engine. So right here you would have retarded the intake, so the intake wouldn't have opened yet. It would have waited until the exhaust valve is closed before it opens, and that's because you retarded the intake. Retard means to hold back or delay, so you delay the intake opening. And remember, if you delay the opening, it's going to open later. It is also going to close later, right? So the intake valve is pushing down. Now, as a matter of piston to valve clearance on the intake side, the same thing is true. If you had retarded this intake, it wouldn't have been so deep down into the piston pockets, right? It would have been up here for a little while longer. So this is why, to increase safety on the intake camshaft side, you retard the intake camshaft timing, right? So there we go, it is pushing down. This is compression stroke, exhaust, intake, compression. Now again, remember, when the piston is going down, your exhaust valve, before the piston hits bottom dead center, your exhaust valve would have been opened already. So it's not the piston alone pushes the gases out. Some of the high pressure gases that are currently in the cylinder makes its way out as soon as the valve cracks open. It makes its way out through the exhaust port. This is all pressure differential taking place right here. So greater pressure on the inside than what is out there in the atmosphere causes this thing to push itself out through the exhaust port. Now, as this pressure dies down, okay, pressure is peaking right now, it's at 27.4. As this pressure dies down, see, it is reducing to 21. The piston will now make its way up and expel the rest of the gases. So this is basically what happens inside of your Honda when you install, well, whether or not you install big cams. This is what happens in any 4-stroke engine. So now that you install your big cams, you have to be careful of your piston contacting the valve and the valve contacting each other. So that's basically it. And this is Perry, and I hope you learned something.